we're ready to begin. So I'm Jeff Walker. I'll be talking today about learning Rust modules. So in the course of this talk, we're going to cover how Rust modules work, compare them a little bit to languages you might be more familiar with, like C# and Java. And then we'll look a little bit at crates as they relate to modules, and finally the use statement and paths and things. And so you should be able to know how to organize your code into lots of files rather than just doing the simple example of like, oh look, I made a kata and it's all in one file here, even though it's 20 different structs. So a little bit of background where I'm coming from here. I'm a .NET developer. I've been a developer for 12 plus years now. Worked mostly in C#, some in Java, some in C++. So that's my background. I've always loved learning different languages, and that's why I'm learning Rust now. So I have a little bit of experience with other languages, but mostly it's C# and Java. And so I sat right out in that audience last month trying to do my Rust kata, and I couldn't get past modules. I was confused by those. Honestly, Rust modules work differently than I've ever seen modules in any other language work. So it was just a change of perspective for me. It was something where I was bringing certain preconceived notions, and those didn't fit with how Rust works. And so even though the documentation was explaining it clearly, it wasn't making any sense to me because I had this idea in my head that didn't match how it actually was. So it took me a little while to get that figured out. So I went home and got that all figured out, and then decided, hey, I can do a talk on that. So we're going to start by reviewing a little bit how C# and Java do namespaces, just very briefly, just so that if you're not familiar with that, you can see what I was comparing it to in my mind. So we have some examples here of Java and C#. I'm going to mostly refer to C# because that's what I'm familiar with. If you are a Java guy, then whenever I say namespace, just substitute in your mind package. And if I say using, just substitute in your mind import, right? Because otherwise, they're pretty much the same thing. So in these two languages, a namespace doesn't really correspond to files. Typically, we organize our files around how we do our namespaces. But we don't have to do that, right? We could put the files anywhere in that directory with any set of namespaces that don't correspond to the directories. Now, some IDEs would not like that, but technically the compiler doesn't care. So when we compile these languages, we're really giving it a whole list of files and saying, here, compile all these files together. The compiler's going to assemble those, look at the namespace declarations, and put those types where they belong in those namespaces, right? So that's sort of what the perspective I came from. Another thing to note is, in these languages, a namespace isn't really an entity in your program, right? It's just a naming convention. So in this example here, math.numbers.complex, that type could just as well be named math_numbers_complex. The namespace is just something where the compiler is helping us to refer to this really long name of the class, right? And we'll see when we get into Rust modules that that's a little bit different the way Rust works. So that's the perspective that I was coming from. So let's look at how modules work in Rust. We'll start with a pretty simple example. This is the example that you'll see if you're like, oh, how do Rust modules work, right? They'll show you this is how they work when they're all in the same file. So we've got our librs file, and we're writing a little math library here, we imagine. So we've got some number types, we've got a complex type and a rational type, and we've got some trig functions, sine and cosine. Those are actually in the standard library, but for the sake of this example, we'll pretend that we might be writing those. And of course, there'd be a lot more code here, right? There'd be traits and methods and more, and implementations to those things. So this code would be a lot longer. But this just gives us an idea of what would be there. So let's go from the top here. You see, it looks really pretty similar to the namespaces in C# or Java at first glance, right? I mean, instead of the namespace keyword, we've got there the mod keyword for module. But otherwise, we'd say, hey, look, we've declared a module, and inside the curly braces is the contents of that module. And we can have two side by side, which C# allows that with namespaces. Java's packages don't quite allow that. They require that everything in the file be the same package, right? So at first blush, it's like, yeah, this is what I'm familiar with. But then the question becomes, okay, I'm used to putting my code in different files. I don't want to have all my structs in the same file. I don't want to have all my code in one file, right? This could be thousands of lines. So how do I break that apart? And that's when we start seeing the differences between Rust modules and C# namespaces. So let's take a look at how that could work. So we're moving from one file here in librs, and now we're going to break it out. So we're going to move each module into its own file. So we've split out the types that were in the number module into one file, which we put in number mod.rs. I'll talk about why that is in a minute. And we've split out the trig functions that were in the trig module to another file, trig.rs. Now, looking at this as a C# developer, I'm just like, what is going on here? Because I look in these files, and there's no declaration of what module that code is in, right? When I read trig.rs, there's nothing in that file saying, this is the trig module, right? That seems really strange to me as a C# developer. The key to understanding this is actually back in the librs file. You see that there's still, instead of like a using statement or an import statement, there's still a module statement there. So what's happening is we're still declaring our module in librs. That's the line, the pub mod number and pub mod trig. Those are the lines that are actually creating the modules still, right? But when the compiler there sees the semicolon instead of curly braces with all the body, that's its cue to say, oh, I need to look somewhere else for the source code for this module. So these module declarations are acting kind of like include statements. If you're used to C or C++, you know the compiler will go, oh, you've got an include statement, I'm going to pull that file in. The difference here is that that happens in the preprocessor, so that's a textual, I'm just going to take the text of this file and insert it here. This is actually the Rust compiler understanding this, so it's going to parse those files separately, and you're not going to have weird, you know, unclosed string causes this other file to seem to be invalid or whatever type issues. So what's happening here is the compiler sees pub mod number. It's going to search for, in two places, for the code for that module, since it has a semicolon at the end of that declaration. The first place it's going to search is in module, a directory named the module name /modrs. And the second place is just a file named modulename.rs, right? So those are the two places it's going to search for. The first way is useful if you want to have further submodules. So if we wanted to have number and then some other, you know, number-related functions inside of that, a submodule, having a number directory would allow us to have further submodules, right? But if we, you know, don't really need submodules, we just want things to be grouped together, we can just use the single file variable. One nice thing to note about this is that if the Rust compiler sees both files, so like if we had both number directory mod.rs and also a number RS file, it's going to report that as an error. So the good thing about that is you're never going to be sitting there going, looking at some code going, I just changed this code, why isn't it showing up? And the reason is that it's actually looking at the other file and you don't realize it. You won't have that problem. It's going to report an error and say, hey, this doesn't make sense to me. You've got two files for the same module. So remember I said that when we compile C# and Java, we're really giving it a list of files. So here with Rust, we're doing something different. We're always just compiling one file, and then that file is essentially including the other files, right? So we're not giving the Rust compiler a list of files. We're giving it a single file that includes each subsequent file. So looking at this, we're like, well, great. Now I understand how to split my module into different files. But if you come from that C#, .NET, Java background, you're like, wait a second, I want my complex type to be in one file and my rational type to be in another file, because, you know, there's 10 methods on each of those, and that's a lot of code, and I want to organize my code well, right? And so looking at this, you're like, well, I'm not sure quite how to do that without putting them in separate modules. So there is a little trick for that is not obvious. So let's see how we would do that. And I forgot to say, if you have questions along this, feel free to raise your hand and we'll get those questions answered. So, yeah.
Is there any kind of standard naming conventions, like in other languages and kind of different languages kind of default to a certain pattern, keep collisions at bay?
I haven't seen any, but I just learned Rust, so I could have missed it. My experience with Rust naming conventions is that module names are going to be lowercase, and they're going to be way too short and way too terse, right? So you're going to look, and it's not going to be, like in C# or Java, you're going to see this nice module name that's fully spelled out with no abbreviations, and it's going to be really clear. Of course, this does this, right? No, it's going to be more like your C-style naming, where they're just going to be like, of course, I to A means integer to alphanumeric string, like, So I don't know any other than the fact that obviously STD for standard, but I don't know of any other conventions beyond that right now. I'm sure that's something that over time will develop in the Rust community. So, okay, so I was saying, how do we go about putting each of our types into its own file? But we don't actually want them to be in their own modules, and so it's not obvious how we're going to go about doing that. So this is how we do that. We actually do put them in their own modules, but then we have a trick, to make it appear to the outside world, the users of our library, that they're not in their own modules. So we're focusing here just on the number module, and I've split out the two struct types, right? So in our number mod RS, instead of having the two structs directly there, we've made two new modules, complex and rational, right? And moved those types into corresponding files for those modules. So that should be pretty familiar from what we saw last time, right? But what's different there is, notice that there's no public keyword in front of those module declarations. So this is something that does not exist in C# and Java. A module can be public or private. So because there's no public here, those default to private. So that means that anyone who's outside of the current module is not going to see those modules or anything that's in them from outside, right? So they're hidden inside this module. Then we have these use statements. So use is like import or using, but the difference is those can be public. So when those are public, we're not only bringing the name in for use inside of our module, we're re-exposing that name to people outside of that module. So it's making it appear as if the complex struct and the rational struct are actually in the number module. But technically, they're in their own modules as well, right? So someone who is using this library is just going to see these two structs are in number for them. So that's how we can achieve, breaking out each type or little thing into a separate file. And in fact, you could use this technique if you really wanted to totally change the structure of modules that was visible to a user of your library versus how you organize your code. If you wanted to split it up one way that made sense based on the implementation, and then expose it in a totally different structure that made sense based on usage, you could do that by sort of distributing it in files according to what made sense to you, and then use the using statements along with more module declarations to rearrange where those all publicly appear. Okay.
So when you do pubmod, that only exposes classes and methods that are also declared pub.
Yeah, so the public module declaration means that you see it as a module in the module it's being declared in, and so then anything that's public inside of it is also accessible.
Okay, so that's why you have to say pub there, because somewhere else you're saying pub mod number.
Right, so down in, let me think of it. I want to make sure I'm getting your question right. So this is what we had before, right? We had the two public structs inside of the number module. And now we're splitting those out into their own files. And we've now made these module declarations private, but the number module is still public, right? That still exists. We didn't change that. So did that answer your question, Mary?
Yeah.
Okay. Okay, so let's talk about crates. Yeah.
One other quick question. So on that previous slide, so I cannot say pub mod number dot complex, or like I can't go down levels.
You mean you're declaring them?
Can I say
or
pub mod number dot complex that would like go down into?
I don't think you can, because the mod is what creates the module, right? And so
So nothing in complex and rational in this case is going to be directly pulled out. It would always have to be through the number module.
I'm getting nods, so
Okay.
someone understands your question better than I do,
Okay.
apparently,
I was
yes.
confused about that.
So the number module is public, because you declared it as public in librs. And then
Right.
complex and rational are both private modules,
Okay.
because they exist within the number module.
Okay.
And those are not re-export, those are not public modules.
Okay. Got it.
So anything in number RS can reference those, but they're not re-exported outside of that.
Okay. So how is so there's no concept in Rust of a tiered namespace?
Well, okay, so there is. I think I'm going to get into this a little bit later, but remember I said that a namespace isn't really like a thing, whereas in Rust, a module really is a kind of entity, right? And so
Mod
when
is not a namespace.
right, there's a difference there, right? So when you are declaring a module, you're making an entity, and that's why you can't say, you know, module this, module this, module this. But you could, like if we go back to our starting code here, with the curly brace syntax, if we wanted to nest our modules, we could do that by declaring more modules inside the curly braces, right? So you can make nested modules. You just don't make them as a single declaration, because if you think of these as each kind of like a class or a struct or something, they're their own thing, obviously. Then it makes sense why you can't just say, you know, module A.B.C.D, right?
Right. So then how do you avoid including the global module name, you know, like names, like there is no global module? It's like, I mean, like everything's put into a crate.
Yeah, okay, so crates is our next topic.
Okay, cool.
So let's talk about crates.
Perfect, thank you.
Yeah. Okay, so we've been writing our number library here, and we're going to make a crate out of that. So everything that we're compiling, building, is some kind of crate. The equivalent in, you're shaking your head no?
No, there's a bug.
Oh, okay, I'm sorry. So the equivalent in C# is what they call an assembly, which is like a DLL or an EXE. The closest equivalent in Java is a jar file. It's not quite the same thing, but it's similar, right? So basically, a crate is your unit of deployment. It's either a library or an executable or so forth, right? And you use cargo to build those, and you declare the properties in your cargo file. So we have here a cargo file for the library crate that we've been working on. You can see we've given it a name, a version, who its authors are, and then we've listed some further dependencies. So those dependencies are crates that have been published on crates.io. So you can go out there and explore what crates are available. And we can actually specify more complex version requirements. So we could say, I want version this and up, or I want something in this range of versions and so forth. But for simplicity's sake, I just went with a specific version. So when we build our crate, Cargo is going to go out, download those crates from crates.io, and then reference them from our crate, right? So then the question becomes, how do we use those crates code from inside? So we were about to talk about how to actually use those crates that we had referenced, right? So the cargo file tells it, hey, these are the crates we want to use, but how do we actually refer to that in our code? And the way we do that is with the extern crate keywords. So we just extern crate and then the name of the crate. That brings that crate in as a module, essentially. So essentially, the crate itself is basically a module, right? So the primes crate becomes the primes module in your system. And so that's what he meant when he sort of said there's no global namespace, because every crate that you're going to work with is sort of its own module that you're going to be dealing with, right?
Even internal ones, like you can have internal crates that are not on crates.io and all that.
Yeah, even your internal crates, that's how they're going to work one thing to note there is if you go out on crates.io, some of the crates have dashes in their names, except there's a little catch because a dash is not a valid character to use in the name of a module. So this is something you just have to be aware of. When you refer to it from your code, you need to replace that dash with an underscore. I'm also showing another little feature there, which is you can use the as keyword to rename the module or the crate when you bring it in, right? So if for some reason, following the standard Rust naming conventions, you decide that media types is just too long for you to type, you can shorten that, which this does not seem to be out of practice for how Rust people like to do things. I'm giving funny looks over there, but well, it's not the number module, it's the num module, for example. You know, I mean, right?
It's not as verbose as C#. It's not as bad as other languages.
I will agree with that. I will agree. Okay, so that's crates and how they correspond to modules. So I've mentioned a few times how modules are more than what namespaces are, right? Namespaces, like I said, are just really a way of having long, complicated names for classes. And only classes are allowed to be in namespaces, right? With modules, we can have more things in them. We can have structs and traits in them, but we can also have functions directly in them. We saw how sine and cosine were just functions hanging out in that module, right? But even more than that, we can have static variables. So that gives our module potentially state, which makes it kind of akin to like a singleton in, you know, C# or Java, where there's a single instance of the state of that module, but it could potentially hold state and change over time as the application's running. So the way we do that is we declare that with the static keyword. There's a bunch of limitations on static variables. So they have to have a static lifetime, which is that apostrophe static that you see there. That's a specific lifetime that the compiler understands. So most lifetime names, it's just whatever you're picking, right? The static lifetime is actually a name that the compiler has pre-declared, and that means that this will live from the beginning of the program until the end of the program. The type must always be specified. So, you know, with a let statement, you can have the type be inferred and be implicit. With static, you have to spell out the type name. Accessing a mutable static is an unsafe operation. So you're going to have to think about using some kind of locking mechanism. The reason for that is if you think about it, the compiler cannot prove that you're not accessing that static from multiple threads, right? So from its perspective, there could be a problem there. Maybe there's not, depending on how you use it, but you're going to have to tell the compiler, I know it's unsafe, I'm going to deal with that. Another limitation is they can only be initialized with constant expressions. So you can't say my static variable is equal to the result of this function call, right? That has some really interesting reasons behind it. So if you're familiar with C#, Java, even C++, they all allow static variables to have, or their equivalents, to have non-constant initializers. But that introduces all sorts of complexities, because then there's questions like, well, what happens if there's an error or an exception inside of one of those initializers? Who is going to catch it? Because it's not being called from main, it's happening before main, right? You get into questions like, well, what order are they going to execute in? What happens when the initializer for one variable accesses the other static variable that isn't initialized yet? What's happening? What's the state of that, right? So the designers of Rust made a decision that they didn't want any of that complexity. They also wanted to improve startup time, right? So rather than saying, well, before I can enter the main method, potentially a bunch of code has to run to initialize all this stuff. Instead, they said, okay, well, we're going to have these be constant initializers. And that way you know the first line of your main method is pretty much the first bit of code that's running anywhere in your app. This actually has interesting consequences for the way statics work. So, you have things that are on the heap and things that are on the stack. Statics are actually their special space. They get their own special way of working. So essentially what's happening is the compiler is writing all the static variables values directly into the DLL, and then that is being mapped into memory, and that section of memory that it got mapped to, that is where the static variables permanently live for the lifetime of your program. And it can do that because it knows this variable will always be there the whole time I'm running. It's not going to go away, it's not going to move around, right? The final limitation is that they can't implement drop. And that's basically for the same reason that they can't have non-constant initializers, right? Then we'd be like, well, what order do they get dropped in? When do they get dropped? Do they always get dropped? I left my main method. How many drops are left to run after that, right? So that's a brief tour of static variables. But just to point out the fact that modules can have state in them, and so that means you can do some interesting things with modules sometimes. Final thing. So we already saw extern crate, pull in a crate, and we saw some use statements. The use statement, the colon separated values there, that's what they call a path. So I just wanted to talk briefly about some of the things you can do there and one little thing to remember. So a difference between the use statement in Rust and, say, the using statement in C# or the import statement in Java is the use statement brings in the actual name, the final name that you're declaring, right? So in C#, you're saying bring in everything in this namespace, right? Implicitly, you're just naming the namespace, but you're really meaning everything in that namespace. That's not how Rust works. In Rust, you're actually bringing in the specific name that you are declaring. So that final name in the path is what's being brought in. Because of that, there's some options to be able to bring in more names. So you can use the little curly braces with a list of names if you want to be able to bring in multiple names from a single module. Or you could even use the star if you really did want to bring in all the names from a module, although I think that's a little bit frowned on. People just say that they want to be clear on what you're referencing, right? And just like with the extern crate, where you can use as to rename it, you can use as with a using statement to give it a different name in your module. So either a name that's shorter or makes more sense to you, or if you're going to re-expose it, you could actually re-expose it with a different name if that was appropriate to the situation. So anytime we talk about using statements, those paths are always relative to the root. So notice there that starts with the crate name of math or the crate name of primes. Even if we were 5 modules down, we would start with the crate name and go from there, right? It's not relative to where you're at, it's relative to the root. However, if you have a path somewhere in your code, if you're just calling a function and you're like, oh, I need A, : B, : C, then those paths are relative to your current module, right? So if you, for some reason, need an absolute path in your code, you can just prefix it with : and that means start from the root, now go on. That does give you a way to reference things without using a use statement, I don't know that that's a good idea. I mean, if I'm reading your code, I probably want to go, oh, these are all the things he's using right up front, and then read through the code. So that's what I had to talk about with Rust modules. Thank you. Again, I'm Jeff Walker. You can follow me on my website, Walker Code Ranger. I've actually got a blog post that covers this same material if you wanted to go back and reference that. Is there any questions? Okay, thank you.